Hey, y'all. Uh, I think we can kind of start the webinar. Welcome to the Georgetown University Wargaming Society webinar. I'm Walter Kunkel. I sometimes host these things along with Sebastian and Nick. Today we have with us Professor Pijus Krūminas. I'm sorry if I've mispronounced that, my friend.
No, that was perfect. No, that was so good. Yeah.
Okay, well, there we go. He's an associate professor at ISM's kind of University of Management and Economics in Lithuania. He studies simulations and game theory, as well as kind of the social sciences. And this is sort of the provenance of his lecture today. Pijus can give you a better introduction into his work than I can, but he teaches a class in Lithuania on wargaming as well that has produced some interesting student games, seemingly. And without further ado, you're free to take it away.
Yeah. Thank you. So yeah, let me just quickly share my screen. Yeah, thanks for the invitation, first of all, and the introduction. Really happy to be here, and nice to have so many people joining. So what I will talk today about is basically how I see wargaming as a tool of modeling in social sciences, specifically in relation to other types of modeling. And we'll come in a moment to why I chose this topic. Just to briefly what we'll talk today. So we'll start with the aim and introductions, and then I'll switch to an example of how I came basically into using games more extensively in classroom. But I also think it illustrates how games can learn, or wargaming can learn for other types of models that social scientists use. And then we'll discuss these things a bit more in depth. So first of all, a couple of words about me. So I have bachelor and master's degrees in political science with focus on comparative and European politics, but I did my PhD in economics, and economists do like their modeling in different kinds, of course, mostly mathematical. So I did my PhD here at ISM, the university that I worked at, which is basically a business school, though I teach less in management areas and more in economics and political economy programs. So I've been teaching at ISM now. I've counted for over 13 years, and most of those times I've used games to lesser or greater extent. I also did some teaching at other institutions, including our military academy. Again, they're specifically focused on games. I've worked quite a bit and still do as a side job policy consulting, mostly in innovation-related areas. And then since 2020, so just before COVID hit, we've launched this wargaming course at our university, which was a double the challenge because it was a new course, it was a new type of course, and it also went online half semester through, which definitely made it more difficult and challenging to use tabletop games. So we switched to Vassal, at least to an extent, but yeah, it made things way more challenging. So for about 5 years, I've been involved more actively with wargaming, as specifically as a method, not just using a game in one class or another, but having a subject devoted to it for several times, and then using also it for research purposes. Some of our students use wargaming as a way, or gaming probability as a way of collecting the data that then they analyze. So we are starting to extend the method application more broadly, and this focus, my background in political science and in economics, as I mentioned, it gave me quite a bit. We've had quite a few lectures on modeling of different ways to model our social reality, whether it's something very mathematical and empirical, or if it's something more theoretical like game theory. So that's where it comes from. And what I want to talk about today specifically, so the aim is to discuss wargaming as a social science modeling approach and how it relates to these other different types. I will offer my own definitions, and I think I should get to some caveats here. First of all, there are definitely numerous types of models in social sciences, so I'm not planning to go over an exhaustive overview of how we can model our social reality, but I will focus on models that I'm the most familiar with, so I naturally can talk a bit better, at least, about them than the other models, so the ones I use in research and in teaching. And also it reflects, my subjective considerations. It's not to the level that's the perfect footnote reference I saw somewhere was stated that the idea was revealed to me in a dream. So it's not that kind of subjective consideration, so more experience-based. But yeah, be sure to take it with more than a grain of salt, or we can later discuss whether it makes sense or if it doesn't make sense, which may also be the case. And one more thing, I will not discuss big data, large language models, or similar ones, because when I use the word model here, one of the key characteristics for me in modeling is explanatory capabilities. And the big challenge with these large language models and big data is that a lot of them are actually black box. So they provide the output, but you're not sure exactly where that output comes from or how it is created. So that explanatory capabilities are lost. So we will not go in that direction. So why I think this question is important, and I think there are a couple of points worth mentioning. First is that each approach to modeling our social reality is unique, and it can reveal parts of our reality. It also has, each of them has advantages and disadvantages. So you can have, and I've had classes where you have people coming from very different directions, not ever agreeing on anything during seminars. Or you can look also for complementarities, where one approach with its flawed assumptions and everything can actually inform another approach to highlight the different aspects of the phenomenon that we are studying. And the second point is also that if we discuss wargaming in relation to these different types of methods, it also helps us to better understand what wargaming can take from these other approaches and from this existing research, and what it can also can give to others. Now, when I proposed Sebastian this topic, it was before we had this great paper by Dr. Banks about the epistemology of wargaming and how wargaming creates knowledge released. But I think it's very relevant for today's topic because it's what it looks like. And if you haven't read the paper, please be sure to find it and read it. What I think is important mentioning is that Banks looks at what characteristics make wargaming unique. So how it creates or generates knowledge different from other knowledge creation methods. And he mentions 5 different aspects. So one, it's representativeness. So that's the model is not, wargaming is not too detailed and not too specific. It's also not very abstract. Second is that it has human participants making decisions that are consequential and that they provide feedback to the same human participants that then build upon it. Third, that it includes adjudication, whether it's rigid adjudication from the rules, where rules set everything, to sort of free-form games where adjudication is based, solely on the discretion of the white cell, for example. Fourth, that it is immersive, and 5, that it's also bespoke design, so with a specific target in mind. So Dr. Banks mentions these are key characteristics in the ways that wargame is different from other ways to create knowledge. And this relates a lot to what we will also discuss today. So unsurprisingly, I'll also look at his definitions that he sets in the paper, which says that wargames are bespoke models, and that's, the emphasis here is mine, designed to represent actual or potential events which future human players engage in consequence-based decision-making, which includes mechanisms that immerse these players and which possess adjudication procedures for choosing actions, determining outcomes, and determining system dynamics in the wargame. So Banks also agrees that wargame is a model that has these characteristics that makes wargame-based models different from other modeling approaches. Now, of course, I've already used the word model quite a bit, but I think it's also relevant for us to discuss what a model is for our purposes today. Because when we talk about models, you can have many things. That's on the right-hand side, you see a model ship from the Age of Sails game, or Sails of Glory, maybe. Sorry, I might messing up the name of the game. So it's a model ship. you see the model of our world in one of the ancient maps, which is basically a model representation of our Earth. And then you see an input-output model that the economists use to see the connections between the different sectors of input and output, how it travels, and so on and so on, which is basically just a mathematical description of the process. So when we say models, models can take many different forms. And we look at models that take different forms today. But what I think is important for our purpose, the most important for our purpose, is that a model, first of all, it's a description of reality, whether to the past, the present, or expected future reality with some sort of social reality. And the model is an abstraction, so we make it more simple. We, cut everything that's not necessary, simplify the reality, and for what specific purpose is this? We can provide an explanation of that reality. And when I talk about reality here, of course, I have in mind social reality. So yeah, so three elements of a model for our purposes today: description, simplification, and also an explanation. And that explanation, again, is why I also not going to discuss the large language and similar models here, because I do think that they're missing that explanatory part. So we'll start with an example of how these other types of models and what they are and wargaming can be connected. And for me, it started with two books. I'm sure one of them is very familiar to most of you. That's Philip Sabin's Simulating War. And the other is Principles of Comparative Politics textbook. So I know back in 2014, 2015, I've got a course to teach on Introduction to Comparative Politics. So I started reading the book, and on the side, I've read Simulating War. And for me, somehow the two clicked, particularly on one topic. Now, comparative politics, as you usually know, it deals with the political processes that happen within a country, not between countries. So not really about wars. It's not, international relations, which is a more relevant topic. But one of the topics specifically piqued my interest and resonated well with what Professor Sabin discussed in his book, is basically when we talk about with students about democratic transition. So there are two questions. So how do they happen, and why they're difficult to predict? So if you think of a country that is not yet a democracy, so a dictatorship of some sort, what happens is that democracy is sort of a public good. So public good means that if you live in a democracy, you can use it, and you cannot take it away from anybody else. I mean, you vote, you express your opinion, others can do the same. The fact that you vote doesn't limit the opportunities for others to vote. So democracy in that sense is a public good. And with public goods, we have a particular problem, which is collective action problems. That is, when many people have to work to get that public good, they don't necessarily have strong individual incentives to do that. So to give you a more academic example, if you imagine a group work at some seminar in class, and you have a group of 5 students, if they all get a similar mark, then personal incentives to contribute to the project may not be very, very, very high. So a similar problem can emerge when we talk about democratizations, that individuals may simply, due to collective action problem, may not be highly incentivized to contribute. Some of them will be, but not necessarily others. And this may help us to understand why transitions into democracy are rare. Of course, dictatorial governments tend to also use their own means of squashing the opposition and not allowing the transition to happen, but there are also lack of incentives. So, however, if we look at this democratic transition problem solely from the perspective of this collective action problem, then it doesn't really help us to understand why transitions happen and how transitions happen, because it doesn't provide us a pathway or an explanation, so a model of why a democratic transition would happen and why they are difficult to predict. And the textbook that I've mentioned discusses one type of models, which is tipping models from Quran 1991, which says that, okay, so one problem with organizing protests that could lead to democratic transition is preference falsification. So in a dictatorship, as a citizen, even if you're very strongly against the government, you are disincentivized to reveal your true preferences. Why? Because, well, if you say that you don't really like the government, you will be punished in one way or another, depending, of course, on the type of the dictatorship and on the level of authoritarianism in that country. But you have, as a citizen, an incentive to hide your true preferences in terms of politics. But when protests grow and more people join the protests, incentives to reveal these preferences may start increasing, meaning that, many people are already out there in the streets. They're still out there. Maybe I should join the protest. And each individual, according to this model, has a personal revolutionary threshold when that individual decides to join the protest. In other words, once a sufficient amount of people are protesting, I say, okay, now I'll join too, because many of us are already here in the street. And what this can do is this can help us understand why some of these transitions are so sudden. For example, in the transitions to democracy in 1989 and 1990 in Central and Eastern Europe were quite sudden, or at least not predicted to happen in such a rapid succession. So if we formalize it a little bit, we can look at several societies, each consisting of 10 individuals. So let's say society A, society B, society C, and society C with a tiny modification. So how to read the model is as follows. So we have 10 individuals, each number representing an individual. So a society A has 10 individuals, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. And the number here, what it represents how likely or when an individual joins the protest. Individual 1 in society A joins the protest when nobody is participating because the value is 0. So he needs 0 other persons participating in the protest in order to join it. Then person 2 in society A needs 1 participating, and so on and so on and so on. So what we would have is that in society A, everybody would be joining the protest because the first person needs nobody, the second person needs 1, the third person needs 2, and so on and so on. Now, if we look at society B, on the other hand, what we would have is a break and a revolution or democratic transition not happening. Why this would be the case? Because person A, individual A would join, individual 2 would join, third individual in society would join, but the fourth individual needs 4 other persons participating. Before him, only 3 persons joined the protest, so they would not participate. The same would happen in society C. If we look at it, nearly everybody has very low revolutionary thresholds. That is, they are willing to join the protest quite early on, but it's not enough. So the first person in the society C joins, but nobody else would join. And if you look at it from the outside, because of preference falsification, you certainly don't know the actual preferences of the society, members of the society. What would happen is that you would not predict society C to transition to a democracy. However, if only 1 person of the 7 whose revolutionary threshold is low would join, or would change the preferences due to whatever reason, maybe the government policy change became more drastic or whatever, if their threshold level decreased, then suddenly everybody joins the protest. Okay, so this is the basics of the model that we covered with student. And then I thought, reading Sabin's book, because in that book, Professor Sabin, what he does is he looks at these warfare and provides a card spiel, so a simple card-based game to depict, I think it was Napoleonic warfare, and that you can very, very easily play. And by the end of the book, the whole rules are provided and everything. And I thought, okay, so is there a room that I could turn this model to make it clearer for the students into a game-based model? So transition from descriptive mathematical explanatory model to something that is more interactive and focus on behavior. So the question then, is there a room? And of course, if somebody asks you that question in the presentation, the 99% of the time, the question is yes. So let's proceed in the approach to the approach I used to turn this model into a game. So there are several considerations of what the game had to cover. One was that population. So you have to have population with individuals, just like in these societies here, with public and private preferences. So you have to have this hidden information of some sort about the citizens. Then to get the game more engaging than just, a solo game or basically a solitaire game playing the cards, there had to be potential for conflict, and players would have to have more agency than just looking at these societies here. So instead of having, a fully random distribution of preferences, you retain some randomness, but you also have to give agency to human participants, so that we talk about the game, not the descriptive mathematical model. And then, of course, if you're in conflict, then you likely want to have government representatives. And of course, if we look about sequences of numbers, then there's one very good tool in games that we can use for that, and that's, of course, the standard playing cards. So each standard playing card, ranging from the 2 to 10 or from the ace to 10, could have a number that would represent the threshold of the individual. So each card would represent a group of individuals with a specific revolutionary threshold. And that's basically then the opposition players would have to do, is they would have to construct a set of cards, of a predefined number of cards that would, let's say, if you play the card on the table, then it participates in the protest. However, what you also have to do is you have to start playing with the lower cards and then increase the cards. So you can only play a 3 when you have played a 2. You can only play 4s if you have played 3s, and so on and so on. So we have to build that set of cards on the table, following the same logic or similar logic to what Kuran did in his tipping model, so that you start with the persons who are most likely to participate in the process, and the others' requirements are met, so you can play the cards. And display is enabled by lower cards to make things a bit more engaging. Also, each suit of cards represents a different group within the opposition, so to create the potential conflicts there as well, but we'll get to that in a moment. So that's the first part of the model. So ranging from this mathematical description of the society with individuals represented by numbers that describe when they join the revolution. You use cards to basically depict the same situation, but also give players agency on when they play each card. So when they put specific group to participate in the process. Now, as I've mentioned, another thing is that, the game should also have some conflict. And so we should involve the government that should be able to respond. So otherwise, you would draw the cards, you would play the cards, and the game would sort of end. So tipping models that we've covered, what they do is they show how citizens behave, but they don't tell anything about the government. They just describe society and explain why it's difficult to predict transitions or when transitions can happen. So if we want to add conflict dimension between the citizens and the dictatorial government, so how could we do that? And if there is room for government to open the door to democratization. So within the topic, within the same textbook on comparative politics, we also had a game theory-based models that described when dictatorship or dictatorial government may decide to sort of open up a little bit for the opposition to enable broadened dictatorship, but still control the government. And it sometimes fail if they miscalculate when the opposition is strong or low. So borrowing from this model, and just to illustrate it, if you think of the Poland in the late 1980s, when it's still run by the communist government sort of agreed to some electoral rules that would give the Solidarity movement some seats. It's just that they miscalculated the actual support that Solidarity had, and then lost in the end after some switches also in the parliament and so on. So we won't get deeper into that. But so there is a room for the government in actual models that try to explain some of these social phenomena, political phenomena, to also miscalculate and fail in trying to keep the dictatorial government running, but just simply failing to do that. So what we did is that for the government, we kept the face cards that would depict specific actions, such as to illustrate, you have this society playing out on the table, where each card, as I mentioned, shows how likely particular person or a group of persons is likely to participate in the process. And so if you remove all of the thirds, then everything higher than that collapses from the game. So that would be, for example, one of the powers that the government would have. Now, of course, the game would need additional work and more balancing to be a fully engaging game. But for the seminar purposes, it worked, and it still works. It gets updated bit by bit. But what it basically did is it took a simplified approach to society in a dictatorial regime, which is on the verge of a transition. And in addition to simplification and explanation that was already there in the model, the game allowed to combine two different models and include space for decision-making and feedback. So having the structure of the game where opposition draws the cards, they play the card, and the government does the same, there's also room open for betrayal. So when the government can say, okay, I'm now with the opposition, or the opposition player switch to the government saying, okay, I'm now want to be in the broadened dictatorship. So the way it looks is that we have this game-based model, which, first of all, on the left-hand side, it borrows the core framework from the typical models used to describe and explain these suddenness of democratic transitions. You have other models, such as these game theory-based models, that add to it. And, well, that's something that outside of the scope of these more standard models in social science, you add decision space for a human decision making. That is, you give agency to the players and to the participants to make decisions. And yeah, so that's basically it for an illustration how the sort of different social science models can be married in a gamified format. Now, if we come back to a broader question of modeling and social sciences, is the description, abstraction of explanation that we use to define the key characteristics of social sciences, of models at the start, it leaves still a little bit in the open, or not a little bit, a lot in the open, because we have very many different ways to describe and simplify. If we just come back to these models that we had here, that's one way to describe a society, relations in the society, in the dictatorship. That's another way to explain how democratization happens. So the thing here is that we have very many different ways to do that, even if we take the same question, democratization. And each approach defines what, or puts boundaries on what we can learn and what questions do we get answered. And the way I suggest is that we split our models or group our models into relationships and behavior. So models focused on relationships between different factors, and models focused on explaining or modeling behavior, and then how each of them relates to wargaming. So that's my proposal for the following part of the presentation. So just to provide you an example of what I mean, relationship-based models and behavior-based models. So in relationship-based models, for example, you could have a linear model which says, okay, so increased employment level also increases the level of taxes that the government collects. So one directly, and well, it can be nonlinear, but let's assume in a linear way, affects the other. So you have two parts of two factors that you want to link, and you just say, okay, one increases the other, one decreases the other, and that's it. So basically, you just define that there is a relationship, and it's a positive, negative relationship, and that's it. Now, when we talk about behavior-focused models, these models, I suggest, try to explain how humans behave. So it's not only the factors that are linked together, but it also looked at decision-making and behavioral aspects of social reality. And that could be, game theory. It could be agent-based modeling. Yet we'll get to these examples in a moment. So first, let's look at some relationship-focused models and how they can relate to wargaming. So here I'll specifically focus on two examples, that is linear regression models, because you'll find them very in very many different places. As I mentioned, my background is political science and economics, so it's definitely everywhere there. And we'll also look at systems dynamics as examples, and these are just examples, as I mentioned, and I'm not going for an exhaustive overview of models, but just for illustration, for illustrative purposes of how these models can be linked to wargame. So just to give a brief recap of what a linear model is, we'll look at the linear regression here, where A equals A plus B times X plus epsilon, which is basically has the following thing. So Y represents the thing that we are trying to explain. X is the factor that we think can explain that thing. And then we have different coefficients. For example, what if X is equal to 0? And basically the epsilon says, okay, so we can't really measure everything, can we? And to provide an example, that's from a paper that my colleagues and I wrote on skills and change in the Baltics after during the transition and afterwards, which basically says, okay, so on the Y part, so the left-hand side of the equation, you have the skills, high skills divided by low and medium skills, basically represented the extent to which high skills are found in the labor force, and then everything on the right-hand side tries to explain it, whether it's is investment in machinery, investment in buildings, other variables, and so on. So if you look at the table, there are many different variables. Now, what's basically the idea of this model? Because it is a model, it says, okay, so investment in machinery directly contributes to the distribution of skills in the society, in the labor force. Investment in buildings also does the same. So basically you take two factors and you say, okay, there is a link between them. They are related in some way or another. If you have empirical data, you test that, you find if there is an actual relationship or if there is no actual relationship between them. And that's it. Another type of model, which I would say also has this relationship focus, could be system dynamics, which is a bit more complex in the say that it looks at complexity and dynamics of the relationship. The linear models are usually, very static. They don't have this change over time. They just say, okay, so what kind of relationship do we have between different factors? And if we have a relationship, that's a good model because it helps to understand something about the society. Even if we don't have a relationship when using empirical data, it's still revealing that something is not correct. Now, system dynamics look at things a little bit differently because they look at feedback loops, stocks, and flows. And basically, if you've ever seen this graph, and I think you might have seen this graph, that's the infamous graph about the US policy in Afghanistan and all the different related factors. So that's sort of something akin to the systems dynamics model, but to very simplify it, this is how it could look like. So if you look at the A part of the figure, you have the population as the key variable at the very center. And, if you have a larger population, you have the direction with a plus sign, the arrow with a plus sign leading to birth, meaning that larger population, you will have more birth. If you have more births, you will have a larger population. On the right-hand side of the same figure, you see, if you have a larger population, you will have also an increase in deaths, and which would lead to a decrease in the size of the population. So you have these several factors counted in that allows for the feedback loops and also allows you to run actual simulations saying, okay, so giving the numbers in the population, the rates of birth, and so on, so that you can try to model the whole changes in the population using it. But in the very basic sense, at least in my view, it's still a model that describes different factors, but it doesn't really talk as factors that are found in our social reality. But it doesn't really explain a lot on how people behave. So again, it's focused on relationship between factors. It's not focused on explaining how, why, and what people do. So the challenges here are basically that, you have relationships. assumed, hypothesized, even estimated if you have empirical data, but not really engaged by anyone. So that you have just, there is a relationship, the strength of the relationship, the direction of relationship, but that's about it. Is it a model? Yes. Or are these models? Yes, because, they describe reality, they simplify reality, they don't take everything into account. Even this one likely doesn't take everything into account, however exhaustive and exhausting it looks like. Because it doesn't really involve any human decision making. Even if it's about humans, even if it's saying that a person's learning impacts the salary that they will get after some years, so the education they receive, it is about human behavior, but just to say that the two factors are linked. It doesn't really add this explanation of how behavior happens. Of course, behind each of these models, there can be a lot of theory, but the model itself is a simplification which focuses on the relationship. And then, of course, you have limited uncertainties. You have error terms like the omega sign or epsilon here, which says, okay, we can't really measure everything perfectly. We can't really know everything. So there is room for error. But those uncertainties are very limited. So now, of course, there is some challenges that these models face. But these are also relevant for when we are considering war games, because war games also tend to have these relationships. Some of them are very linear. Some of them can more be closer to these the system dynamics or with increased complexity. Because if we have a war game as a model, then different methods, different elements or different factors and variables included in those war games do interact not only with players, but something that exists outside of players' decision space. So, for example, if there is a hex encounter war game where you have terrain modifiers, then that's basically a linear relationship. Your attack becomes twice as weak or twice as strong, depending on the type of the terrain. So terrain is directly linked with the outcome. Well, the human will have the capacity, the player will have the opportunity to decide whether they want to use it or not, but that relationship is already existing in the model. And of course, for that, you don't really not necessarily need a lot of theory or a lot of econometrics or whatever. But it's still that type of relationship. What came to my mind when I was thinking about this at this point is this upcoming GMT game by Gunnar Holmbeck, the Weimar Republic, which is basically includes as a very standard economics model the Phillips curve, basically, which says that the inflation and unemployment are negatively linked, and the game has this. So it has this track, and there had been discussion during playtesting about it. There is the track where you have if you are higher in employment, then you have lower inflation, and vice versa. So they go directly. You either go to one side or the other side. So basically, that is the reflection of the model that we have in economics. So we have these factors in war games, and understanding how these different models focused on relationship between different factors work can also help, whether you just look at something specific that is relevant to the topic that you're modeling, or general logic of those models. Similarly, the system dynamics view of feedbacks, flows, and stocks. So flow is basically the rate of change that happens between in the way the one factor affects another. They can also help you provide a good overview of the interactions between the different elements of the games. The more elements you have that each interacts with everything, you don't necessarily need to have these conspiracy theorists whiteboard with arrows leading from everything to everything, but you can try to distill it as a game, as a complex system, as a system dynamics model, and try to run it just as a simulation to understand how these different factors work. So that's one thing, is these relationship focused models. They do not likely, form the core of wargaming, because wargaming still is mostly concerned about behavior and decision making. But it can provide, these types of models can help inform a war game approach in terms of the environment where the players will have to make their own decisions. So the other type of models that I propose is the behavior-focused models. And here I would like to talk about two of them. One likely quite familiar to many of you, one maybe a bit less familiar. So that is game theory and agent-based modeling. So just a brief recap, just in case. So if we talk about game theory, basically what it is, it's a tool to explain strategic situations. So it's less about how one thing affects another thing, but it's more about how two or more agents make decisions when their actions of one agent affect the payoff or actions that the other agent can do or can achieve, basically asking, so can I achieve my goal? Maybe, but it also depends on another player. So I think when we go to the ancient Greek writing, I think it was Plato or maybe somebody else. So now I'm a bit afraid to lie. Which one of the key philosophers here, who already in his writing says, okay, so now if I'm at the war and I'm standing in the front line, so should I retreat or should I not retreat, depending on what others are doing, and so on and so on. So basically, game theory is about thinking about what others are doing, how it affects my own payoffs, and how can I counteract anything that other players in the game do. And of course, the sort of the most standard model that you find and the most discussed model that you find is a prisoner's dilemma model, which is basically just for the illustration purposes here. If we talk about a situation such as a nuclear arms race, you have two countries that can cooperate and say, okay, we don't want to arm ourselves, let's disarm and don't spend on arms and decrease the risk of accidental nuclear war, or they can defect and actually develop these nuclear weapons. And if you look, the higher the number in the table represents the better outcomes for different players. So naturally, cooperate looks better situation than defect. But because each of the countries would have in this situation an incentive to defect from the situation. So if your opponent is cooperating and doesn't develop weapons, while you develop weapons, you gain suddenly a huge advantage over them. Each country, irrespective of what the other player does, actually has incentives to defect, lead to this suboptimal situation. So this is how game theory models work. And of course, they themselves have a lot of challenges. That is, they make a lot of assumptions about what actions players are able to take and what payoffs do they get from it, as well as assumptions about probabilities and agents' understanding of uncertainties and constraints that they face, including, for example, how agents, whether they're countries or people or firms, manage to deal with uncertainties, calculating risk and everything. Then another criticism or challenge is the tendency to focus on representative agents, especially if we talk about individual or firm behavior. Then you say, okay, so there is a representative firm, there is a representative person, and this is what they would do in a particular situation. Game theory also looks for optimal solutions. So just like we did here, we sort of found the equilibrium where each country would have incentives to defect and they would simply defect. So it's actually quite heavily focused on finding that particular equilibrium situation that would play out in the situation described in the game theory model. And very often, though, there are exceptions to have a static structure so that you play the game out, even if you repeat the game over some time or several times, it still remains quite static. So, it's a model. It can't involve everything, but there are quite a few quite valid criticisms of how game theory has shortcomings in modeling behavior. And by the way, I also teach game theory, so I'm not very much against it, but yeah, it has its own problems when we talk about how it represents our reality and how it models it. Now, where, however, game theory and wargaming can overlap is more than the previous game models that we have discussed. It talks about agents and agency. It doesn't give agency in the sense that players can make different decisions. It's usually assumed that they will make an optimal decision, or if it's a decision that includes uncertainty, they will make these decisions with certain likelihoods. But it still talks already about agents and what they can do. what's very common to wargaming is, it's an action payoff structure. So players or agents in the game theory model, they take actions and they get a payoff from that. And that payoff can also be affected, of course, by other players involved. If you use repeated games, similarly to what a turn can do, you can get feedback to the players so that they can escape from this prisoner's dilemma situations where they both players get non-optimal outcomes. And it can also account for imperfect information, and war games often do include that, whether through cards, through a full Kriegspiel, double blind experience, or in other different ways. So they can try to account for imperfect information. Actually, in some of the documents on wargaming, for example, that's from the Wnorowski's Wargaming Practitioner's Guide from the Doctrine and Training Center of the Polish Armed Forces. They then spent quite a bit of time talking about game theory, the dilemmas it proposes, and how it's linked to wargaming, or how it could be linked to wargaming. But there are also divergence from wargaming. So even if there are similarities, there are also differences. And one of them comes in agent characteristics, that in game theory, you tend to have representative agents that do not really have individual characteristics. So it's quite a homogeneous set of players depicted. While in war games, you tend to have them specific, even if if both players represent the military of different sides, it will also have enough difference that these two armed forces would have in reality. The second point of divergence is decisions and how they're made. So in game theory models, basically, when you're modeling and solving the model, you're looking for optimizing and finding optimal solutions versus as opposed to actual decision making that would be made by the players in a war game. And the third point would be scope of feedback. So within a game theory model, it's usually about repeating the same game if you have this dynamic element, versus continuing the same game and allowing to evolve it in a war game. Actually, there are some papers using game theory or discussing how game theory could overcome that and allow for more feedback. For example, if we are modeling situations related to climate change, so that each repeated game would get a different conditions, different environment set because of the changing climate, but that's still not really used a lot. Whereas in a war game, as an experience, you get consistently feedback and can easily incorporate changing environment within the same one game, within the same model. And then, of course, the scale of decision space, whether for actual human involved in a war game or for an agent or a player depicted in a game theory model, is very different, meaning that in a game theory sense, it's usually way more limited, whether it's giving a few discrete choices, such as in this example of prisoner's dilemma here, or whether through continuous choices, for example, such as provided here, and I'll come to it in a moment. But decision space is also way more narrow in game theory to make it workable, because you're trying to find a solution, and the more different possible actions you include, the more difficult it becomes to identify those solutions or find those solutions and find those equilibria. So here is an example of analytic narrative, which sort of overcomes some of the challenges, or it aims to overcome some of the challenges, such as a high abstractiveness of models and high level representativeness of agents by taking a case study and formalizing it. And that's an example from a paper by Kreifor. Actually, it's a book chapter on medieval Italy. So, trying to make to use game theory to explain some very specific situation. To give a little bit of a background, if you imagine medieval Italy, it has a lot of independent city-states that tend to fight one against another, and within these city-states, there tend to be different families, clans, who would like to, control the city. And when they're very much opposing one another, that also creates risks for that city-state. in that if these core clans are fighting among themselves, then another city-states can more easily conquer. So what happens in some of these city-states is that they sort of hire a CEO to run the country on behalf of the shareholders or the different families or clans. So the CEO, called Podesta, would have the power to make decisions. Of course, each clan would still have incentives, to have the governor on their side and then implement policies that they find attractive. So, for example, this model provides a continuous decision space, so not a discrete one where you have cooperate or defect as in our first example, but the more continuous decision space marked by RP, which basically reflects how much they offer to the governor to turn on their side, who then can fight or don't fight the clan one. So basically, just to illustrate, you have these decision space where from 0 to 100% of money from a clan can go to the governor. So there is some scope for these differentiation in game theory models, but definitely is still lesser than in war games. Same about the representation of a particular situation, because at the higher level, this model still remains quite abstract compared to most of the war games that we have, whether as commercial or professional applications. Another divergence, and that's from the Wargaming handbook from the UK's Ministry of Defense, is they argue for the use of roleplay and wargaming by saying that there have been experiments and there's some evidence that when considering conflict situations, roleplay is a better predictor of outcomes than expertise or actually trying to solve situations for game theory, and that includes the reference to the whole paper. I just wanted in this case to focus on the doctrine document as opposed to an academic paper. Now, the second type of behavioral models that I wanted to talk about is agent-based ones, which takes a bit different view from game theory. Still wants to explain how people behave or how institutions or organizations behave, but instead of taking a representative individual, whether an individual person, country, or firm, this says, okay, there can be many varied agents of the same type, having different characteristics. And instead of trying to find an optimal solutions, they are given rules on how they would behave. So that's basically simulating an artificial environment populated with agents that are given rules, what they want to achieve, what they need to have in order to function, how they interact with the environment and agents, and how these interactions evolve, which can lead to interesting insights at the macro level. So you begin at the very low micro level, you focus on what an individual can do and what characteristics individuals have, and then you see what happens. And again, to make things a bit more easier to follow, let's look at a particular example, the model of wealth distribution that's based on Epstein and Excel 1996, where basically you have an environment with resources and agents roaming the environment that collect and consume resources. If they're in a space with a lot of resources, they collect those resources, they consume it over time, and so on. Then each individual agent is given rules. They can be specified, they can be randomized on how much they consume of those resources, how far they can go, etc. So this is how such a model could look like. This is from the NetLogo web implementation of this wealth distribution model. And basically, if you launch a wealth distribution model, that's the first thing that you would see there. So this rectangle, black to yellow, represents the environment with resources. The lighter the color, the more resources you have, or the more yellow a particular pixel is, the more resources it has. And then you have different agents, what the NetLogo calls turtles, but they do look like people here, roaming about the environment and trying to collect and consume these resources. As you see, on the left-hand side, you see the numbers of representing different characteristics, so ranging from the environment, how many people you see, so how far they can see. So if they can see 5 pixels, they will see where within 5 pixels radius they can get most resources and they will go there. how much they consume through metabolism, life expectancy, etc., etc., etc. So you can set these individual aspects, and they're basically given very simple rules here. Yeah, if you see a place with more resources, go there and consume what you can there before going elsewhere. So that's very, very micro level thing. Talking about rules that individuals follow. It's not talking about optimizing or anything as in game theory models. It's just like, okay, so you have these rules, you have this environment, you have these changes surrounding you, do what you want. And so if you run a game for more time, what you could get is, for example, this situation. As you see, there are way less yellow here. And also at the bottom of the figure, you see the change in the figures. So basically what the model says, okay, so we have this individual level rules that agents follow. You start from this micro level. And then even if you didn't write it in the model or didn't include it in the model, what you have is this micro level phenomena emerging. So on the bottom left, you see the class plot representing how many of those individuals modeled would be considered lower class because they have way fewer resources than others, how many would be in the middle class and how many would be in the upper class. The second figure basically plots the same thing just through a histogram. Then the two other ways of measuring inequality in the society, Lorentz curve and Gini index, are also depicted. So what it does is that, yeah, you give individual agents randomized characteristics. You give them specific rules, and then you just let it run. You don't talk anything, you don't include yourself in the model anything related to class, related to inequality and so on. It emerges automatically from how individuals behave given the environment that they have. And so instead of solving for something optimal, you let it run and you see the interactions and the results of these interactions. Now, of course, this type of modeling also comes with its own challenges. First of all, you have to make a lot of assumptions about model parameters, especially if you want it to be a realistic model. So you have to think of really how varied are different individuals and what kind of rules they follow. And the second challenge is that calibration and assessment of micro to macro pathway. So how well the model actually explains what happens at the macro level based on the rules that you set them at the micro level. And of course, it can also be very resource intensive in terms of computer power if you want to model a huge societies or huge group of individuals with a large number of parameters, large number of rules, and so on and so on. On the other hand, if we look at agent-based modeling and wargaming, you can definitely see some overlaps in that both of these approaches look at heterogeneity in agent characteristics, so variation in agent characteristics that they tend to be different, and they can have potential for learning over time. So you can have it in agent-based modeling. You certainly do have it in wargaming when players learn from their own mistakes, or well, a better situation, better scenario is when they learn from those mistakes of the others. Then you have a role of the environment, which is strong, which can be importantly, which can be changing. We have focus on interactions between agents and environment, as well as between agents and feedback. And although, sort of these rules that you give the individuals are different from the rules in the wargaming sense, they still adjudicate or define what the modeled individuals do. So it doesn't give them full agency over what they're doing, but it sets the pathway within some limitations. So it sets the rules, then random variation can also occur. However, if we talk about divergence between agent-based modeling and wargaming, so one thing that you have is, of course, that you don't have true agency on agent-based model. You give them the rules and they follow the mathematical description of the rules that you give them. You don't really have, you have more automation than actual agency. The second point is that you have, well, still a high abstraction. If we come back to these 5 elements of wargaming that Dr. Banks mentioned, it's definitely not at the level of representativeness that wargames are. And also you would have this difference in terms of, bespoke design in wargaming, having something particular in mind and more generic with most of the, or at least many of the agent-based models. And this basically comes to the links to the core part, or the sort of summarizing part of my talk today, is so how can we link wargames, or what are the links between wargaming and these other modeling approaches? So I try to structure my thoughts in a single figure initially, and basically, if we started going from these relationship-focused models towards wargaming, what we see is that we can sort of ask a question how active a model is, leading from aggregate models talking about relationships, not about individuals, to individuals modeled through game theory, which look mostly, not only, but mostly at payoff maximization or optimizing decisions. Then you can look at agent-based models, which are more flexible and in terms of agent behavior, giving them the rules instead of just trying to find this equilibrium situation. So again, the model becomes a bit more active, to finally going to wargaming models with actual decision models being incorporated there, because humans make decisions there, so making the game more active. Why is it relevant to understand the logic of different models? So first of all, it helps to better appreciate the reality, because, well, each model provides a certain angle on whatever we want to understand, while several can help us be more informative from very different perspectives, from just understanding the linkages to understanding the behavior there. And most importantly, it can help us also inform our own models, whether we're talking about developing war games or not. So basically, what I think wargaming as a model, as a way to model social reality, can take from other approaches is as follows. So, well, from game theory, what it can take is definitely the structures of strategic situations. If you look at many of the games, you can have either ingrained or emerging prisoner dilemma or other types of situations that are very standard in game theory. So it can help provide a structure. We sometimes do with students this exercise. I don't think we did it last year, but we definitely did it earlier, where they would be given, and they already have had by that point game theory classes, some game theory model, and then they would try to gamify it. Sort of, okay, so now you have this description, you have the optimal solution of the situation. Okay, how could you turn it into a game where players would have agency, and players would represent the same agents represented in the game theory model, but with greater decision space, with greater uncertainties, and so on and so on. So what it does, it can help provide a structure for these situations, and it also can be a good exercise to building wargame models based on what's already out there. In terms of agent-based models, what I think is important is that they help us understand how from these micro level individual agent behavior, higher level phenomena can emerge, such as inequality in the previous example. Again, of course, this might be more relevant if you have a war game which models many different individuals, but it still can be informative. And for relationship-based models, they, of course, help us understand the links between the environmental elements in our war game models, whether it's diral modifiers for combat tables, whether it's economic systems, or natural resource use, climate change, or whatever we want to put in the game, and that forms an important part of the game. But it's not really up to but it's not really making a decision itself. It can be affected by decisions, but it's out there in the environment. At the same time, what wargaming can give, and I think it's not a sort of one-directional relationship, but a mutual exchange can happen, is that wargame can inform about behavior in terms of game theory. again, optimization and maximization of payoff has attracted quite a lot of criticism in the literature, and Wargame can help us understand that why. I mean, even in my game theory classes, we do sometimes run the very simple game theoretic models live to see just how, you know, the results diverge from the situations that we have. And I think Wargames, being more complex, can certainly help us understand whether the score structures that we use to develop the model, if we borrow them from game theory, actually work and to what extent they do. In terms of agent-based models, wargames can definitely help inform on the rule structures of the behavior and the definitions and the boundaries of decisions that are being made and how decisions lead to payoffs and how the feedback loops work. While for relationship-based models, what wargame models can help is helping to, well, to understand the treatment of predefined relations, so how humans react to the relationships that you model in your environment and how they adapt their decisions based on that. So I think there's good scope between of learning from other methods when we work on the wargaming models, just as I think wargaming can help also make other approaches better or more informed of their potential shortcomings or potential complementarities with research being done in different areas when we talk about specifically about modeling approaches. And yeah, that would be the core part of my talk today, and basically with the conclusion that, yeah, game structure can use insights from different types of models, just that we had in this beginning with this example of the card game depicting the democratic transitions, to use game-specific tools, specific rules, cards, playing cards, to mimic the elements in these different models. And playing game models can also help us understand better these models and what they tell about reality. So thanks for listening. You can contact me via different means, email, LinkedIn, X. I also do sometimes write on Substack about using games in the classroom, and new post will soon appear about what my students did this year, so how they model different social phenomena. One was gerrymandering, the other was privatization process in the 90s and the Soviet transition, then Orleans, the siege of Orleans in the Middle Ages, and the current situation in Niger. So they all still link back to, well, modeling our reality from different topics using wargaming as an approach, but also informed by other other methods, specifically likely game theory, because I've had a lot of that in the previous courses. So thanks for listening, and I'm happy to answer any questions or discuss any topics that you might have.
First of all, thank you, Pijus. I won't lie, a lot of that went over my head. I kind of
Sorry
got
about
lost.
that.
It's not your fault at all. I kind of got lost after the mathematical models of the dissenting, the mathematical sets, which were interesting and I did understand. And then we kind of veered off and was like, oh, damn, all right. But hey,
Okay,
hey.
I'll keep in mind that for the future, yeah.
Well, you did mention, I did have a question kind of before, and people are welcome to put questions in chat while I'm talking. You had mentioned the social sciences are kind of sometimes infamously regarded among academics and statisticians for kind of fuzzy or weak analytical modeling. Do you think there's a risk of wargaming's kind of falling into the social science bracket here, and not being regarded as rigorous an analytical technique or modeling technique?
Oh, I do think that the risk. I think the risk also, at least partly, comes from the word game in the title, and I think that even among the social scientists, it can be viewed a bit more critically, just because of that and because of that background, which I don't think makes sense, but and it can definitely be the case. So I think that there is a risk. There is a risk related to that. And I think what's important is to understand and discuss specifically what wargaming is and how it is different, and both its advantages and its drawbacks over these other types of models so that it, maybe it makes fewer assumptions about what people do in specific situations, because people have to play out these and make decisions in these situations. So I think it also relates to how we communicate the specifics of wargaming as a method.
I've got you. So it's sort of a potentially wargaming has its work cut out for it, you would say, in proving itself. People have tried to, I guess, come up with different ways to say game, but you really can't. You have to
You
kind of
can't
keep it
escape that. Yeah.
They've used serious gaming and stuff like that. Any other questions from the chat? You're free to unmute yourselves as well if you'd rather talk in person. Oh, Zach's talking.
Yeah. So I'll just read out the question. So
Thank
your
you.
model suggested that there's a tipping point whereby democratic movement is still enough confidence in enough people to turn out and demand change. Do you think there is research to suggest the opposite is true for anti-democratic movements or protests? That's a very good question, and I'm not sure. I'm not sure about research as such, but I think it could even work in the same direction. I mean, if it's an anti-democratic movement, and if there are, if they're growing, then again, more people are like this. So I think they could follow the similar dynamics there as well. In that case, but I'm not aware of any research. I think that's something that could also be wargamed. Just need to do a bit work on that. But I think it could definitely use some inspiration from the tipping models. There. What would differ, of course, is our understanding of the preference. So whether people would be inclined to really hide their own views of the government or not so much. And I think that could be an interesting topic to engage with. And actually, I think I'll look into if any works has been done on that issue. That's an interesting point.
It seems like people really appreciate the talk and kind of the line of research that you're bringing into the field.
Excuse me?
Oh, did you say something? I'm sorry, you kind of cut out there.
No. Yeah, sorry, excuse me, because I had a cut for you as well, so I didn't.
It's all good.
Didn't get the last.
People seem to really appreciate the talk, was what I was saying.
Okay, that's nice to hear. And
Perfect.
yeah, and just looking at there are some other comments if there's anything else. Yeah, there is some about prisoner's dilemma and its suitability on the situation. Then, of course, it's not for all. Definitely not for all situations, for specific structures. And I think, game theory also provides different types of models including cooperative models where players do cooperate in the end. And that also can provide interesting variation in structure for different war games.
Mm-hmm. I know I've used it as a model or like a miniaturized form of it in certain game mechanics as well. But hey, thank you for the talk. This recording will be available on YouTube. All right. I'm going to